Okay, beta. So basically, if you look at this screen, I have taken a photo. Okay. The same question I was making you understand yesterday. It is the same question. Okay. So if you look up here, the ester concentration is given up here, and the OH concentration, if it is 0.2 mole per dm cube, you got run A. So this is run A. And if you got the OH minus ion concentration 0.4, then it is run B. Okay. So now, my dear students, if we want to find out the order of reactant with respect to this reactant which is present along the y-axis, so I told you you have to find it by half-life method. And half-life method is, if you look up here, the initial concentration is 0.001. Its half, that is 0.005. Okay, so you have to look how much time is required. So the time required up here, that is almost 12 minutes. Yeah, it's 12 minutes. And if you make the half of this 0.0005, so that would be 0.00025. So it would be up here. So I haven't got the scale, so that is why it would be little bit. Okay, now if you see this gap, my dear, it is again 12 minutes. Okay, so if the equal interval of time is required for the given concentration to become half of its original concentration, then it would be a first order reactant. So it means this ester, that is the first order reactant. I told you about it yesterday. Did you get it?
Yes, sir.
Guys, did you get it? Okay, now the order of this reactant has been calculated. It's first order. And if the time would become double, let's suppose up here we got 12 minutes, and this difference, that is, let's suppose 24 minutes. So this one would become double. So then it would be the second order reactant. And yesterday I told you, if you got a straight line like that, so that would be the zero order reactant. Okay. Now, my dear, we are going to find out the order of reactant with respect to this OH minus. Okay. Now, to calculate the OH minus order, what should you do? You should draw the tangent. Okay. Tangent should be drawn up here like that. For this curve, the tangent should be drawn. Okay. And from this curve, the tangent should be drawn like that. Okay. Did you get it? So I haven't got the scale so that I could draw the straight lines. But you should draw the straight line, then you will get the perfect answer. Okay. Now you should take the gradient of these two curves. Okay. The gradient formula, you know that the gradient formula is y2 minus y1, that is equal to x2 minus x1. So this is the formula to find out the gradient of each curve. Okay. So if we want to find out the gradient of this run A, so that would actually be the rate of A. Okay. So the y2 value is 0.001. So you should write 0.001 minus this curve is coming up here. Okay. So this point, that is 30, 32, and 34. Okay. Sorry. This is 0.01 and it is coming at this place, so this is 0. So minus 0. This is y1. This is y2. And this is x2. And this is x1. Okay, so the x2, my dear, that is 34 minus 0. Did you get it?
Yes, sir.
Yes. Okay, if you find out the gradient of the run B, so it would be the rate of run B. Okay, so it would be again y2. This is y2 because it is starting from this place. So this is 0.001 minus 0 divided by the x2 is this one. So this is almost 18 minus 0. Okay, so if you calculate it, my dear, any one of you could tell me what is the answer of plate A if you divide
2.94 10 is power minus 5.
2.94 times 10 raised power minus 5. And what about the grade B? 5.55 times 10 raised power minus 5. Okay, so now you got the two rates, my dear. Now you should use the formula C2 over C1, its power n, that is equal to R2 over R1. Okay, so the bigger concentration from these two, which one is the bigger concentration? Anyone could tell me? What is the concentration? It's 0.4. 0.4 divided by 0.2, its power n is equal to, so run B has got this rate. Okay, so it is 5.55 times 10 raised power minus 5, and uh, run A, it has got this rate. So 2.94 times 10 raised power minus 5. So this is 2 power n is equal to almost 2. Okay, 2 and 2 that would be cut. So it is the first order reactor. So it means your ester along the y-axis, that is the first order, and you calculate it by means of half-life. And this one thing which is given up here, its two concentration are given and two curves are being made. So find out the gradient of these two curves by drawing the uh, straight lines, okay, and find out the gradient, and it will give you the rate. And then using the formula C2 over C1, you can find out its order. Okay, so both the orders, they are first order. Now you should make the rate equation. So the rate that is equal to K ester concentration and OH minus concentration, because both have got first order, so that is why no need to put 1 at the top of it. Now if you want to find out the value of K, you should take any of the rates. Let's suppose I'm going to take the run B rate. The run B rate, that is 5.55 times 10 raised power minus 5 is equal to K. The concentration of ester, the initial concentration should be used 0.001, and the OH minus ion concentration, the run B OH concentration, that is 0.4. So 0.4. So if you solve it, you will get the K value. And if you want to find out the units of the K, you can find it like that. बेटा, I'm asking
सर
you.
सर मुझे एक चीज़ ये नहीं समझ आई कि ये जो अभी आपने एस्टर और ओ एच माइनस की वो लिखी कंसंट्रेशन, उसमें आपने एक तो 0.001 इस्तेमाल किया है ग्राफ से, दूसरी आपने सर
जी
ऊपर से क्यों ली है?
भाई, ये जो रेट है ये किस चीज का रेट है? रेट बी का है। तो भाई रन बी का जो कंसंट्रेशन है OH की वो 0.4 है, तो 0.4 ही लेंगे ना। अगर तुम
अच्छा
रेट
ठीक है,
जो है वो
अच्छा ठीक
ये
है
वाला,
ठीक है।
अगर तुम रेट ये वाला यूज करते 2.94, यहाँ पे 2.94 लिखते, तो भाई फिर तुमने जो है ये रन ए का था, रन ए का, तो रन ए की कंसंट्रेशन लिखते 0.2। ओके,
अच्छा ठीक है, ओके सर।
okay guys, I'm going to share the screen with you people. Okay, so which question you have to attempt, let me tell you about it. ये जितने भी graphical questions आएंगे, you have to attempt them. Now have a look up here. This question is very interesting, my dear. Okay, if you look at this question, he did not specify any single reactant up here. He just wrote the word concentration. Okay, and he said in the first experiment, the ligand PR3 was in large excess and CrCO6 was measured with time. The results are shown. So this graph is made with CrCO6. Okay, this graph. Okay. Now he has given you these readings, and these you have to draw this graph. Okay, on the graph paper of this graph would be of PR3, and it is a straight line. I think if you draw this line, that would be a straight line like that. Okay, so this straight line of PR3, if you draw it, okay, I'm just making you understand. And this one CRCO6. Okay, now the order of this one, as it is a straight line, so this one would be a zero order. And if you want to find out the order of this one, you should use the half-life method. Okay, so for the half-life method, what should you do? You should take the half of all these things. Let's suppose uh, this is 0.01, its half is 0.05. Okay, okay, and 0.05 half is 0.025. So it could be like, it could be up here. Okay, so both of these distances, they almost look same. Okay, if you calculate them, so it means CRCO6, that would be the first order. So your rate equation would become rate is equal to K, and CRCO6 is first order, and the PR3, I told you, it would be a straight line like that. If you draw the line, okay, the values are given. So this one would be a zero order. So zero order thing shouldn't be right in the rate equation. Did you got it,
Yes,
guys?
sir. Yes, sir.
Yes, sir.
Okay, my dear. The next, you have to practice this question. You should take a print out of this page and make a graph and do this whole question. Okay, and then there is another question of graph. Okay, up here, question number 7. In the question number 7, he's saying, I'm telling you the question, when the HCl concentration is zero point 0.1 mole per dm cube, this graph is being made. And if the concentration of HCl, look up here, the concentration of HCl is zero point 0.2, you have to make this graph on the graph paper. Okay, you should draw the graph up here. So you will get the two curves like that. This is a suppose graph I'm making. So these two graphs are being made. Now this reactant is present along the y-axis, so you could find out its order with respect to half-life method. Okay, this is zero point 0.2, 0.1, okay, like that. 0.1 half is 0.5. It should be like that. So it looks like the first order reactant. Okay, and the next one, the HCl concentration is zero point 0.1, and in the next curve, whatever the curve you made up here, this curve. Okay, here the concentration of HCl is zero point 0.2 mole per dm cube. Okay, so for those two curves, you should draw the tangent. Okay, you should draw the tangent like that. Tangent. Okay, and then find out their gradient. That would give you the rate, and then C2 over C1 formula, that will give you the order of reactants. Is it clear, guys?
Yes, sir.
Yes, sir. Okay.
Sir, could you repeat one more time?
Yes, sir.
Sorry, Fatma beta.
Could you repeat one more time, Lord Latin?
Beta, I told you that this curve is being made when the HCl concentration is zero point 0.1 mole per dm cube. The other curve you have to make by yourself. These are the values, okay? And the HCl concentration is zero point 0.2 mole per dm cube. So you have to draw these values by yourself on the graph up here. So I'm going to suppose, let's suppose, it
सर
will be a
हमने
curve
कर्व
like
बनाना
that.
कि लाइन ऑफ बेस्ट फिट बनानी है? नीचे लाइन ऑफ बेस्ट फिट लिखी हुई है.
नहीं नहीं, कर्व 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 बनेगा. लाइन ऑफ बेस्ट फिट का मतलब केमिस्ट्री में कर्व होता है. अगर कर्व बन रहा हो तो कर्व बनाओ, अगर
ठीक
स्ट्रेट
है.
लाइन आ रही है तो स्ट्रेट बनाओ. वो सब
ओके.
पॉइंट्स को ज्वाइन करना है आपने. ओके, सो इट वुड
ओके
बी अ
सर.
कर्व लाइक दैट. ठीक है जी. एंड देन if you want to find out the order of reactant with respect to this one which is present along the y-axis, so you should use the half-life method, Fatma. Okay, like zero point 0.2 is half is zero point 0.1 like that. 0.1 half is 0.05, it is like that. Okay, so find out the time taken for each half. So if it is same, then it would be the first order reactant. And if the time would become double, So then it would be second order reactant. Okay. And then I told you, if you want to find out the order of HEL, so you should draw the tangent. I told you tangent for this curve and tangent for this curve, and find out their gradient. Gradient would give you the rate of this one and rate of this one, gradient. Okay. So the rate would be calculated, and then use the formula C2 over C1 power n is equal to R2 over R1. The C2 bigger concentration of HCl, that is 0.2. A smaller concentration is 0.1 power n, and whatever the rate you calculate, just write it up here and then calculate the value 10. Okay, Fatma?
Okay, sir.
So you, all of you have to print out these pages, please. Print out those pages and then do it. If you don't do it, if you got the topical, in the topical you got same type of the question. If you got the topical, okay, so you can you can draw the curves, okay, and then you can find out the answer, okay, if you got your own topical. But if you did not get the topical, please print out these pages and just practice this question. This is question number 8 as well. Okay, so the same thing is written up here. When the NaOH concentration is 0.1 mole per dm cube, this is the curve. And in the second curve, he has given you the value. NaOH concentration is 0.15. So draw all these values on the graph, okay, and do the calculation and find out the order of reactants, and then find out the rate equation. Did you get it? So the question number 8. Okay, so I think these 3 questions we have to attend.